Yeah, I think my voice and screen is audible. Recording is perfect. So let's start today's session. Uh, admit. Hi Krishna, my screen is visible, right? Okay. So then let's start. So I gonna solve the assignment that has been given in week 8. So let's start. So the first question is as follows. So let x1 x2 screen is not visible. Okay, then let me present it again. Now is it visible or not? uh, uh, it is not visible. Okay, thank you. So let x1 x2 xn, these are identically distributed random variable, independent random variable, which follows normal with mean mu and standard deviation sigma. And x bar means it's arithmetic average 1 over n. It's been sample mean sample over xi, and its sample variance is 1 by n minus 1 summation I equal to 1 to n xi minus x bar square. Then which one of the following statements are not correct? And the statements are A, x bar follows a normal distribution with mean mu and standard deviation sigma by root n. B, s square follows a chi-square distribution with n degrees of freedom. And C is x bar and s square are independently distributed. And last, n minus 1 s square by sigma square follows a chi-square distribution with n minus 1 degrees of freedom. Then which statement is not correct? So let's go through one by one. So first of all, the sample mean, as we know, the sample mean follows normal distribution with mean mu and sigma square n. That is true. And but SA square, the sample variance, follows a chi-square distribution. That is right, but that degrees of freedom n minus 1. So that means B is not correct. So SA square follows a chi-square with degrees of freedom n minus 1, not n. And sample mean and sample variance are independent. That is also true. And n minus 1 SA square by sigma square follows a chi-square distribution with degrees of freedom n minus 1. So that is true. So that means this A, C and D true, and the false answer is B. S square does not follow. S square obviously follows a chi-square distribution, as you see in the option D, but it follows a chi-square distribution with n minus 1 degrees of freedom, not n degrees of freedom. So that is not true. So that is the first question. Now let us move toward the second question. Question number 2. Okay. Suppose a random variable x follows if distribution with m comma n degrees of freedom also let if alpha mn be the upper alpha percent point of F distribution F distribution, that is probability of x greater than equal to if alpha mn is alpha, then consider the statement. Consider the statements, and the statements are following. I 1 by x follows F distribution with degrees of freedom nm to if y follows T distributions with n with degrees of freedom then y square follows F distribution with 1 in degrees of freedom third is expectation of x square greater than x square exists for n greater than 4, and fourth is f of 1 minus alpha n m so equal to 1 by f alpha mn. So let's check one by one. So first of all, if x follows distribution mn, so what does it mean? So let me means suppose that if y1 follows a chi-square with degrees of freedom m and y2 random variable follows chi-square with degrees of freedom n, then the variable x follows x y1, sorry, that's, let me write it's ym, let me write it's yn. So then ym by m yn by n should follow the f distribution with degrees of freedom mn. Now 1 by x is nothing but yn by n and ym by m, so that means this should follow a f distribution with degrees of freedom nm. So let check that is it correct. First statement that 1 by x follows f distribution with degrees of freedom nm. Yeah, indeed it is true. So that is true. Sorry, that is true. Now let's check the second statement. If y follows t distribution with degrees of freedom n, then y square follows a f distribution with degrees of freedom 1n. So let's check it. So for second, suppose that what is the question? If y follows a t distribution, alright, y follows a t distribution, okay, then suppose the z follows a normal, standard normal distribution and x follows a chi-square n distribution, then y variable z by root over of x by n will follow a t distribution with degrees of freedom n. Now y square follows a f distribution with y follows a t distribution. That means y square is nothing but z square by x square by n. Okay, we know that z square, since z is a normal standard normal random variable, z square follows a chi-square distribution with degrees of freedom 1. That means here we get 1 z square by 1. It's a chi-square variable with degrees of freedom 1, and this is a chi-square variable with degrees of freedom n. That means from the above definition, it is a f distribution with degrees of freedom 1n. So that means the second statement is also true. If y follows a t distribution with degrees of freedom n, then y square follows a f distribution with 1 comma n. That is true. Now x follows a chi-square f distribution. We know the variance of the x we know that the variance of that for question 3, we know that variance of x, if x follows a f distribution with degrees of freedom mn, only exist for n greater than 4. So that means if variance exists, that means expectation of x square only exists for n greater than 4. So that means third statement also correct. Now let's check the fourth statement. Now we'll check the fourth statement. In the fourth statement, the probability that x greater than f alpha mn is alpha, right? This means probability of 1 by x less than 1 over f alpha mn is 1 over alpha. Now we this is nothing but 1 by x follows a probability distribution. Suppose that 1 by x is equal to y, and this y follow a f distribution with degrees of freedom n comma n. So this means we can write it probability of y less than 1 by 1 over alpha mn is equal to 1 by alpha. So this means 1 minus probability of y greater than 1 over if alpha m n, so this is greater than equal to, should equal to 1 by alpha. So probability of y greater than equal to 1 over if alpha m n is let me see. Okay, I did it wrong. I think this is alpha only, not 1 by alpha. So this is alpha, this is also alpha. Okay, so this is 1 minus alpha, and we can write 1 minus alpha as probability of y greater than equal to if alpha mn. So this is nothing but probability that y greater than f of 1 minus alpha nm. So from these two greater than equal to, so these two, from these two equality we have that is 1 minus f of alpha mn is nothing but f of 1 minus alpha n m. So that means this fourth statement is also true. So that means all the four statements are true here. So let's this is the question number second question. Now let's move toward the question number 3. Question 3. Let x1, x2, xn follows a IID random variable. That means identically independent distributed random variable with mean mu. They are normally distributed with mean mu with sigma square, and x bar is sample mean, pi equal to 1 to n xi, and s square is sample variance. Now the question is, which of the following statement is not correct? The statements are, so question is, then which of the following statement are not correct? The statements are following: a root over n x bar minus mu by sigma follows a standard normal distribution. B root n x bar minus mu by s follows a t distribution with n minus 1 degrees of freedom. C variance of root n x minus mu by s goes to 2 as n tends to infinity, and t is the PDF of root n x power minus mu by s converges to the PDF of standard normal distribution as n tends to infinity. So let's see that. Let's see this question. So first of all, these answer is following. Since x1, x2, xn follows a normal distribution with mu sigma square, then root over n x mu by sigma will follow a normal distribution with a mean 0 and standard deviation 1. So the first is true. Now let's see second. Second is also true, that root n x bar mu by s follows a t distribution. That's true. So from the definition of the t distribution, so t distribution means if suppose that z follows a normal distribution and y follows a chi-square n distribution, then suppose that x follows chi-square n distribution, then y or t will do z by root over x by n will follow a t distribution with degrees of freedom n. Now here you see this is a normal distribution and this n minus 1 s square by sigma square is a chi-square n minus 1 distribution. Then the variable t root over n x bar minus mu by sigma by root over of n minus 1 s square sigma square into 1 over n minus 1. This should follow a t distribution with degrees of freedom n minus 1. Now if you simplify this, you will get this is nothing but root n x minus mu by s. So this follows a t distribution with degrees of freedom n minus 1. So that means second is also true. Let's move toward the third. So the variance of these distribution, we know the variance is the variance. So the variance of root n x bar minus mu by s, which is a t distribution with degrees of freedom n, is equal to n by n minus 2. So here n is n minus 1, so n minus 1 minus 2. So if we simplify it, so this is 1 minus 1 by n by 1 minus 3 by n. So if I take limit n tends to infinity, then this will become 1. So that means variance tends to 2, though that is not true. Variance tends to actually 1, so it is not true. Now let's see the third, the PDF of root n x minus mu converges to standard normal distribution. So let us see that where a t distribution, since this is a t distribution with degrees of freedom n. Now let us first see n minus 1. Let us first see that where does a t with degrees of freedom n goes to. So let's check that. So you know that the f distribution is, ft is gamma n plus 1 by 2 gamma n over 2 root pi n 1 plus t square pi n to the power minus n plus 1 by 2. So first, so as if I take the limit, so there will be two limit n tends to infinity gamma n plus 1 by 2 gamma n by 2 root pi n into limit n tends to infinity 1 plus t square by n minus n plus 1 by 2. So let's first check this limit. Let's first check this limit. So this is limit n tends to infinity 1 plus t square by 2 by n by 2 to the power minus n by 2 into limit n tends to infinity 1 plus t square by n to the power minus half. So as n tends to infinity, this will tends to 1, this will tends to 1, and the rest of them equal to, this is nothing but e to the power minus t square by 2. Now let's see what this will tend to. So to do so, we'll use a Stirling approximation. So gamma Stirling approximation. So let's do it. So we know that gamma p plus 1, as in p, if p large, then it will be approximated by root 2 pi e to the power minus p to the power p plus 1 by p plus 1 by 2. So let's put all the things together. So this is, first term is n plus 1 by 2, so this will be root 2 pi to e to the power minus p. So this will be n plus 1 by 2 minus 1 plus 1 by 2 minus 1 p to the power p plus 1 by 2, so that means n plus 1 by 2. Okay, let me write it. this is n plus half, n plus half minus 1 to the power okay, let me see. So this is n this is p plus up, so this will be n by 2, so p to the power, so n plus half minus 1 plus half pi root 2 pi n into same thing for gamma n by 2, so e to the power minus n by 2 minus 1, and that is n by 2 minus 1 to the power n by 2 minus 1 plus up and into root 2 pi. So this will be cancelled. So this is e to the power minus n minus half minus n by 2 minus half, and here also e to the power minus n by 2 minus 1. This is n minus half to the power n. This is n by 2 minus 1 to the power n by 2 minus half. This is, there is n by 2 is here, n by 2. Okay, so now if you take n out of 8, so this will be to the power plus half, this will be n, if you take common of n, so this will be n to the power n by 2, 1 minus 1 by 2n, 1 by 1 minus, okay, so this is not, if you take this, not n minus half, here is again by 2 by 2, so if you take n by 2 to the power n by 2, 1 minus 1 by n to the power n by 2 pi, this is n by 2 to the power n by 2 minus half into root n to 1 minus 2 by n to the power n by 2 minus half, so into 1 by root pi. If you do these calculations, so you will get 1 2 from there, so it will become half, so this n will be cancelled with n, so and only what this will remain 1 over 2 to the power half will be remain there, and this term, the first term will become e to the power minus half. Sorry, the first term will become e to the power plus half, and sorry, this term will be okay, this will be that, and the lower portion will become e to the power half. This is will become e to the power 1, and this is 1 by root pi, so that will be 1 over root 2 pi. So if I now combine these two terms, it will become 1 over 2 pi e to the power minus t square by 2. So this is nothing but a normal distribution with standard deviation 0, 1. So that means this, as n tends to infinity, the ft where t follows a n degrees of freedom converges to a normal standard normal distribution. So that means if this is a n minus 1, so that will also converge to standard normal distribution with degrees of as n tends to infinity. So that means it is also true. So only this option C is not true. Now let's move toward the next question. That is question number 4. Question 4. Okay, let's do the question 4. Assume that the time hours failure of a bulb is a random variable with mean mu and standard deviation eight. If failure times of n such bulbs are recorded, what is the smallest value of n so that the average failure times differs by from mu less than 40 hours is at least 0.99. So let's do it. So x1 x2, suppose x1 x2 dot 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 xn be the failures of n bulbs. Let x bar equal to 1 over n sigma I equal to 1 to n xi, then probability of x bar minus mu less than equal to 40 is 0.99. So we can write it as follows: probability of root n x bar minus mu by sigma, its mod should be less than of root n 40 by 8, should be equal to 0.99. So now we can approximate these by a normal distribution from the central limit theorem. So these will be approximately equal to probability, this is mod z less than equal to root n by 2 is equal to 0.99. So this means z is normal distribution from the central limit theorem. So this is 2 phi z, sorry, this is 2 phi root n by 2 minus 1. So this is not, this is greater than, I think greater than equal to at least, since it is said that at least, so this is greater than equal to, so this should be greater than equal to 0.99. so that means phi of root n by 2 should be greater than equal to 0.995. so which means root n by 2 is should be greater than equal to 2.58. so that means n should be greater than equal to 26.6256. so that's it. Now let's move toward the question number 5. Question number 5. Okay, here it has been said in the question number 5 that the following data represent the number of pop-up advertisement received by 10 families during the past month. This is 43, 37, 35, 30, 41, 23, 33, 31, 16, 21. Calculate the sample mean and sample standard deviation. So let's do it. So sample means simply x bar means summation over all of these. So 1 over 10 summation over all over I equal to 1 to 10, 1 to 10 xi. So you have to add all these numbers. So if you add all these number, so we'll get 310. So that means sample is 31, and we have to now calculate what is the sample variance. Sample variance is s square is, we know that 1 over n minus 1 summation of I equal to 1 to 10 xi minus this x bar square. Now if you, and the sample standard deviation is square root of this, that means 1 over 10 minus 1 I equal to 1 to 10 xi minus x bar is 31, its square. If we calculate it, it is, we'll get it 8.75595. That's it. Now the question number 6 is, question number 6. Question number 6 is as follows. This is in semester marks. In semester marks, this number of student. So it has been given that 0 to 10 marks, how many of the students get 0 to 10 marks? There are 15 of them. Then there is 10 to 20 marks. Excuse me. 35 of them get in number between 10 to 20 marks. 10, 20 to 30 marks get 45 of them. 30 to 40 marks gets 60 student. 40 to 50 60 get 35 of them, and 50 to 60 get 10 of them. That's all. Now we have to calculate what is the mode of this thing. So in which class the mode will be, so that is obviously the maximum of the frequency. So what is the maximum frequency? That will be belong in this, obviously that will belong in this class, in between 30 to 40. So we'll now apply the formula. The formula is given below for the mode. Mode is XL plus F0 minus F1 by F0 minus F minus 1 plus F0 minus F plus 1. Okay, then multiply with C here, where XL means lower limit of the model class. F0 is the frequency of the model class. F1 is frequency of the class succeeding the model class, and F minus 1 is the frequency of the class preceding model class. And C is the length of the model class. Okay, now then here we'll know all the things. XL means 30, F0 is 60, and F1 is sorry, this is minus 1, I think. F of minus 1. So let me put it here. Then mode is XL is here 30, F0 is 60, F minus 1 is 45. This is F minus 1, this is F0, this is F1. So minus and this means this is minus 45, then this 60 minus 35 plus 60 minus 45 into the length. What is the length of this? That is 10. So into 10. So that is 30, and this is 3.75. So all the thing is 33.75. So that means, what is the mode of this data that has been given? That is 33.5. So now let's toward, this is the question number 6. So now move toward the question number 7. So let's write the question number 7. Question number 7 is as follows. Consider the following two data sets. Data 1 is 7, 7, 8, 10, 12, 12, 14, and data 2 is 7, 7, 8, 10, 12, 12, 56. Now we have to calculate here what is the suppose m1 comma m2 denote arithmetic means, and m1 m2 denote median, and S1 S2 denotes standard deviation. Standard deviations. Then which of the following is not correct? Then which of the following is not correct? Options are these: A, m1 minus m2, its modulus is equal to 6, B, m1 less than m2, C, trimmed means of data 1 and data 2 are same, and D is S1 less than S2. Let's see it. So the sample mean M1 is, so let's take it. So 7 plus 7 14 plus 8 22 32, so 44 56 14, that means 70 by my 7, so that is 10. So sample means is 10, and m2, so that is, this is 56 plus 56, so that is 112, and by 7, 112 by 7 is 16, so m2 is 16, and this is median, So this is 7. So what is the median value? Median is 7 plus 1 by 2. So the fourth term is the median term. So 1 2, the 10 is in the both is median. So that means m1 is 10, m2 is 10. Now the first then means this is true, and you can see that B is not true because m1 and m2 is equal, but here it is less than. And trimmed means of data 1 and data 2. So trimmed means if you trim the extreme points, so if you trimmed data 1 from 14 from the data 1 and 56 from the data 2, the trimmed mean will be same because these two data are same. If I trimmed 14 from the data 1 and trimmed 56 from here, so these two data sets will be same. That means the trimmed mean will be same. So that means C is also true. And let's see the standard deviation. The standard deviation of S1 is less than S2. So let's see. So standard deviation, if you calculate the standard deviation is nothing but root over of 1 by n minus 1 I equal to 1 to n xi minus its mean square. So for S1 it is m1, that is 10 square excuse me. For S2 equal to root over of 1 by 7 minus 1 summation of I equal to 1 to 7 xi minus 16 square. So you'll get this is 2.76 and this is 17.67. So you will get these two, that S1 is less than S2, that is also true. So that means only the B, option B is not correct. So that's it. Now let's move toward the next question, that is question number 8. Question number 8. The runs scored in a cricket match by the 6 players are as follows. So 0, 18, 21, X, 91, Y in ascending order. Suppose sample mean and median of the above observation are 43.667 and 28 respectively. Then find X and Y. Excuse me. So let's find it. So how many are there? 1, 2, 3, 4, 5, 6. So this is odd, this is even. So that means median will be median will be 6 by 2, that will, yeah, so that is 6 by 2, 3 third, and plus 6 by 2 plus 1, so that is fourth. So that means 21 plus x by 2, that will be its median, and mean will be, add all the number. That means if you add these numbers, 18 plus 21, so that is uh, 39 plus 91, 39 plus 91, so that will be 130 plus x plus y by 6. And it is given that this is median is 28, so this is 28, so 28 equal to 21 x plus 2, so that means x equal to 56 minus 21, so that is basically 35 is 35. Now if I put it here, 130 plus 35 plus y by 6 is equal to 43.667. So this is 165 plus y equal to 6 into 43.667. So y is 6 into 43.667 minus 165. So this is y equal to 97. So that's it. So that's the answer of it. Now let's move toward the next question, that is question number 9. Question number 9. So question number 9 is as follows. So it is given a table below the time spent in hours. The table gives the time spent in hours by by 60 kids to watch television per week. So the table is as following. So this is time spent time interval. Time interval in hours. This is frequency. This will cumulative frequency. So 0 to 3, 3 children. At 3 to 6, 10. 6 to 9, this is 20. 9 to 12, this is 14, 12 to 15 is 8 and 15 to 18, that is 5. So let the cumulative frequency, this will be 3, this is 13, this will be 33, this will be 47, this will be 55, 47 plus 8, this is 60. Now we have to calculate find the median. We have to calculate the median. Now for that we have to first calculate what is the median class here. So that is total is 60, so 60 by 2, that will be 30, so that will be 30, so that will belong to this class 13, 33. So in this class the median will belong in this class. Now let's calculate. To calculate we have to use the formula of the median. So median is XL plus n by 2 minus NL by F0 into C, where XL is lower limit of the median class, which is lower limit is 6. So XL is 6. Now NL is the cumulative frequency of the class preceding the median class. F0 that is NL. Okay, NL is what is the NL? NL is 13. Cumulative frequency of preceding class, that is 13. So this is 13. F0 is the frequency of the middle class. Frequency of the median class. So that is, what is the frequency? That is 20. That is 20. C is NL. C is length of class intervals. So that is 3 here. And small n is total frequency. So that is here 60. Now put all the things together, we'll get the solution. The median is XL, that is 6, plus n by 2, so 60 by 2, 30, minus NL. What is NL? Value of the NL is 13, by F0. What is F0? Is 20, into C. What is the value of C? C is 3, so that is 6, plus that is 17 by 20, right? That is 17 by 20 into 3. so that is 8.55. so that is the median of this class is median of this table is 8.55. so that's it. Now let's move toward the last question, question number 10. Question number 10 is as follows: the temperature in degree centigrade on 16 days during the month of June in a place were recorded as 34 degrees centigrade, 35 degrees centigrade, 36 degrees centigrade. So 35 degrees centigrade, again 35 degrees centigrade, 34 degrees centigrade, 33 degrees centigrade, again 34 degrees centigrade, 34 degrees centigrade, 34 degrees centigrade, 33 degree, then again 33 degrees centigrade, then again 33 degrees centigrade, then 32 degrees centigrade, then 32 degrees centigrade, 3 degrees centigrade. Then which one of the following is true? So the options are A, 33 is the only mode, B, 34 is the only mode, C, 33 and 34 are the modes, or option D, 35 is the only mode. So let us first make a table. Okay, temperature in degree centigrade, frequency. So this first 32, how many are there? There is 33, 32, 34, 35, 32, 33, 34, 35 and 36 is there, 136 is there. So no, 136 is there, 34, 35 and 36 is there. Okay, so how many 32 is there? First find. It is 1, 2. There are no 32 are there. Okay, 232. Let's how many 33s are there? So 1, 2, 3, 4, 5. So 5 33s are there. Now let's see 34. How many 34? 1, 2 3 4. I think I missed one, so this is 35 34, so 5 1 2 3 4 5 5 30 there. Now how many 35s are there? Let's find it. So 1 2 and 3, so this is 3, so 5 5 10 and 5 15, so and 1 36 is there. So and what does mode means? So maximum, the value at which the frequency is maximum. So you'll get that there are two modes actually, 33 and 34, where the maximum, where the frequency is maximum, that is 5. So here here the option C is correct. That means 33 and 34 are the modes of this data. So that's all. That's is today's question answer session. So if you have any question, you can ask me, or I will end this session here. Otherwise, okay, it seems that you don't have any questions. So thank you for joining. So I will end the meeting here.